Very good morning. Myself Dr. Ruchi Gupta. Today I will discuss OSI and TCP/IP reference model in detail. So OSI reference model, this is basically a base model for the computer network. It based upon the proposal developed, which is proposed by ISO, that is International Standard Organization. It is a first step towards the standardization of the protocols, and it contains the various layers. Basically, OSI model has 7 layers. So we will discuss all these layers in detail. It is called ISO OSI, that is Open System Interconnection Reference Model, which is basically used for the connectivity purpose. So as I already told you that OSI reference model contain these 7 layers. So why there is a need of 7 layers? So the first layer, what is the purpose of layer? So layer, it will use to create a different abstractions as needed. Each and every layer perform a individual task, and all the layers are connected with each other. Each layer, it perform a specified function. It perform a specific layer perform a specific function. The function of each layer, it should be chosen via different international standard protocols. Each and every layer have a different protocols that work to perform operation of that layer. The layer boundaries, it should be chosen to minimize the information flow. Access the information because the layer contains some information through which your data or information is being transmitted from one layer to another layer, and the number of layers should be large enough that distinguish between functions. So this is a complete layer architecture of OSI model. We have 7 layers. So always we have to start with the bottom layer. So a physical data link layer, network layer, transport layer, session layer, presentation layer, and application. We always start from the bottom layer of the OSI model, and we always go from bottom to top. So this is a layers communication between two devices. Suppose if we have a device A, and at the destination side we have a device B, and both the devices want to communicate with each other. So in that case, there is a necessary condition that each and every device contain the 7 layer of OSI model. It will at the source side, and it will also at the destination side. And there is a necessity that a specific layer of the source side will communicate with the same layer at the destination side. For example, application layer in the device A will communicate with the application device layer of device B. Similarly, the presentation layer of device A will communicate with the presentation layer of device B, and vice versa. And we have to connect all the layers. All the layers are to be connected through the interface. All the layers are connected to the interface through the information is going out from one layer to another layer. So, and between two devices, because it is a connective reference model, we have to provide the connectivity. So there is a need of some intermediate routers or intermediate nodes are also required for connecting the devices, 2 or more than devices. So here we have to use some routers or other connecting device, and there is a need of some protocols. So at each and every layer we need some specific protocols. I will discuss that how many protocols are work on that particular layer. I'll discuss in brief. So, we need a specific protocol at a specific layer, and how the data is being transmitted from a device A to device B. Suppose we have a device A and there is a device B, and device A want to communicate with device B. Then first of all, user will interact with the upper layer, that is the application layer, and machine will interact with the bottom layer, which is called the physical layer. So, first of all, the user will put the data onto the application layer. So, it will go through the various layers. It will come out at the bottom layer of the OSI model, that is a physical layer, and physical layer will convert the data into the number of bits or in the form of signals, and these signals, the signals may be transmitted in the digital form through some transmission media from device A to device B. When it will reaches to the destination, then first it comes on the physical layer, it receives the data into the signals form, then the data is transmitted from bottom layers to the upper layer. When it will reaches to the application layer, then the user which is reside on the device B, it will take the information from the application layer. So, we can say that how the information is being exchanged from device. The layers in the OSI model, there, as I have already told you, that 7 layers in the OSI model. So, first of all, we come on the physical layer because it is a bottom layer of the OSI model. So, physical layers, it deals with raw bits in the communication channel. The data is being transmitted in the form of bits. The data is being transmitted in the form of 0 and 1 only. So, the design issues is that it will ensure that one side send a 1 bit, it is received by the other side 1 bit, not as a 0. It means if we have to send 1 bit from the source side, then destination will receive exactly 1 bit, not 0. Now, second one, how many volts should be used to represent 1 and how many used for 0? Because I have already told you that the physical layer is responsible for transmitting the data in the form of bits. So, we have to define that how many volts are to be used. How many nanosecond is to be taken out for sending or receiving the bits. Whether transmission may proceed simultaneously in both the direction. So, how much time will taken from the sending or receiving the bits. How to establish the connection, this is also a key design issue at the physical layer. And how many pins each network connector has and what each pair is to be used for. So, this is the communication process of the physical layer. First of all, the data is coming out from the data link layer because physical layer is directly connected with the data link layer. It is the upper layer of the physical layer. So, the frames, the data is coming out in the form of frames at the physical layer. Then physical layer will divide or it will distribute that data frame into the number of bits. Now, these bits or signals are to be transmitted through some transmission media. It may be a guided or unguided media, and it will go out on at the physical layer of the destination side. Now, this is the process at how the physical layer of device A will communicate with the physical layer of device B. Now, the physical layer, it is responsible of the movement of individual bits from one hop or one node to the next node. Now, the second layer, that is the upper layer of the data link layer, the main task of transmission of raw transmission facility, it appears free of errors to the network layer. As we have to seen that data link layer, the main responsibility of the data link layer is to construct the frame. So, the data is being coming out from the network layer, which is in the form of packet. It will convert the data into the form of packet. The frame, it may be a 16-bit or 64-bit or 32-bit, it may be in any form. Then process the acknowledgement frame sent by the receiver. Another responsibility of the data link layer is that it will provide us the facility of error control and flow control. Error control means that your data is being transmitted without any error, or we can say the data is being transmitted exactly which is sent by the source. It is exactly received by the receiver without any modification. So, it is error free. If any error occur in the channel, then the data link layer provide the facility of error control. Second facility of data link layer is the flow control. Flow control means if we have transmit the data through the channel, if the channel is overloaded or so in that case your packets or your frames will be destroyed due to the congestion or the overflow. So, it also provides us the facility of the flow control. For that purpose, it will use some flow control or error control algorithms. Second facility of data link layer, or the second responsibility of the data link layer, is the channel allocation. So, before the data is being transmitted, first of all, the data link layer provide us a channel. It will allocate the channel through which we have to transmit the data. So, basically the data link layer is divided into two sub-layer. One is the DLL. DLL is divided into two sub-layer. One is LLC and second one is MAC. LLC is a logical link control sub-layer and MAC is a medium access control sub-layer. So, the responsibility of LLC is the framing and error control and flow control, and the responsibility of the MAC layer is providing the channel allocation. So, this is the process that how the data is being transmitted from the data link layer. So, the first your data is being coming out from the network layer in the form of packet. Suppose your data is coming in the form of packet. It is a 64-bit packet. So, the DLL layer, it will divide the 64-bit packet into, for example, it will convert it into the 32-bit 2 frames. It will divide the packet into the frame. So, your 64-bit packet will divide into 32 2 frames at the DLL layer, and then it will go down to the physical layer. So, the data link layer is responsible for moving frames from one hop to the next hop. This is a process that how it works, how the data link layer works. So, this is a device a source, and this will a device B. So, it always provides us a hop to hop delivery. Hop to hop means your data is being transmitted from one intermediate node to another intermediate node through the data link layer. Now, we come on the next layer of the OSI model, that is network layer. So, the main responsibility of the network layer is to providing the routing facility. So, routing means that how the packets are to be routed from source to destination with an optimal path facility. So, routing always provides us optimal path. So, there are two type of routing we will use at the network layer. One is a static routing and second one is a dynamic routing. And it is also used for in the interconnection of the heterogeneous networks. It also responsible for the subnetting, and we can connect more than one network through the connecting device at the network layer. This is the process that how the data is being transmitted from the network layer. So, the data is coming out from the transport layer. Now, the network layer is responsible for converting the data into the form of packet. So, the data which is coming out from the transport layer, it will convert it into the form of packet. For example, suppose we have a 128 bit of data which is coming out from the transport layer. So, it will convert it into the 64 bit of packet. Now, the data is being transmitted from network layer to the DLL layer. So, the network layer is responsible for the delivery of individual packet from source to host to the destination host. So, each and every packet is to be transmitted through the network layer. This is the process that it always provides us source to destination delivery. Network layer is responsible for providing the source to destination delivery by hop. It means the data, if the data is transmitted from source to destination, then if the number of nodes exists between the source and destination, then your data is being transmitted from one node to another node, and these intermediate nodes, these nodes are called intermediate nodes, through which your data is being, through which your packet is being transmitted. Now, the next is the transport layer. The basic functionality of the transport layer that it will provide as a process to process delivery, or we can say it is end to end layer delivery. It may multiplex transport connections from one network connection. It will provide us the various of type of services for the connection. It may be a connection or connectionless. If we are using a TCP protocol, it means it will provide us a connection oriented services, and if we are using a UDP protocol, it means it will provide us a connectionless services. So, type of services is determined when the connection is established. And message belongs to which connection in case of multi-program host. This is the process of the transport layer. The data is coming out from the session layer and it will transfer it into the network layer, and transport layer, it provides us a process to process delivery from device A to device B. So, the transport layer is responsible for the delivery of message from one process to another. It does not provide the delivery of host to host delivery, it only provides us a process to process delivery. Now, it is a reliable process to process delivery of a message at the transport layer. This is one process running on the device A and another process is running on device B, and if they want to communicate through some media, here we are using a internet. So, if we are using a network layer, then it always provides us a host to host delivery, and if we are using a transport layer, it will provide us a process to process delivery. Session layer, it allows, it is a next layer of the transport layer or upper layer of transport layer. It allows us to different machine to establish the session between them, or we can say we can remotely access the machine at the session layer. It basically these are the responsibilities of the session layer. It manages the dialog control. Traffic can go in the both direction at the session layer. It provides us the facility of the token management. Both sides could attempt the same operations at the same time, and it provides us a synchronization facility. So, these are some responsibilities at the session layer. Now, it is a session layer at device A, it is session layer on device B. So, it provides us the facility of the synchronization. Both session layers at device A and B provide the facility of synchronization. So, session layer is responsible for the dialog control and synchronization. The main responsibility of the session layer is the synchronization and dialog control. Now, next upper layer of session layer is the presentation layer. Presentation layer, it provides us some syntax or semantics. So, what syntax we are using to convert the data? So, for that purpose, it provides some encoding methods. It will abstract the data in a standard format. Standard codings are also used at the presentation layer. It converts the different data structures to abstract and back. This is the process of presentation layer. The data is coming out from the uppermost layer, that is a application layer, and it will go on to the session layer, and then it will communicate with the presentation layer of the device B. So, the presentation layer, it is responsible for the transmission, translation, compression and encryption. These are the main responsibility of the presentation layer. Now, we come on the last layer of the OSI reference model, that is application layer. So, application layer contains a variety of protocols which are needed by the users like HTTP, FTP, Telnet, DNS. There are number of protocols are used at the application layer. So, abstract network virtual terminal, it defines the editors and the programs can be written to deal with, or we can say that end user work at the application layer of the OSI model. So, in that layer we use some software to map the functions of the network for the virtual terminal at the real environment, and we can transfer the files in the form of text or multimedia through the application layer. So, these are the this is the process of at the presentation layer. The user will put some data which is called a message. So, message is also received as the receiver side, and one message is sent at the source side. So, the message is being converted into the number in the frames or packets or bits when we have to go down on the physical layer. So, application layer, it is responsible for providing the various services to the user. So, this is the summary of all the layers which I have already discussed, that application layer, it allows access to the network resources. Presentation layer, it translate, encrypt and compress the data. Session layer is responsible for establishing and manage and terminate the connections. Transport layer is responsible for the process-to-process delivery and error and flow control facility. Network layer is responsible for transmitting the data packets from actual source to destination with some optimal route. Data link layer is responsible for organizing the bits into the frames, and physical layer is responsible for converting the data into the form of bits or signals, and these signals are to be transmitted from one machine to another machine. So, this is a complete OSI model which has 7 layers, and when we have to use another model, that is a TCP/IP model. The TCP/IP model, it contains the 4 layers: application, transport, internet and host to network layer. 2 layers are absent in the TCP model, that is presentation and session. These both are absent at the TCP model, and network layer, it becomes the internet layer at the TCP model. So, there is we also say that this is the comparison between the OSI reference model and TCP. In OSI, we have 7 layers. In TCP, we have 4 layers. So, the working are almost same. I have just described the working of those layers which are different names, like internet layer, which is the network layer at the OSI reference model. So, the job of this internet layer is it permits the host to inject the packets into any network and it travel independently to the destination. Packet may arrive in any of the order, but it will rearrange later when it will reaches to the destination with the help of various segmentation and reassembling methods. The main job of this internet layer, it will responsible for delivering the IP packets to the destination. It will provide us the facility of routing and congestion. And the internet layer is a connectionless layer and it use the IP protocol, and it will use the two versions of IP protocol, IPv4 and IPv6. Next layer is the transport layer, which is available at the TCP layer. The transport layer of TCP model, it can be a connectionless or connection oriented. So, for the connection oriented, it will use a TCP protocol, that is a connection oriented protocol, or the reliable protocol. It is a reliable connection oriented protocol. It allow a byte of stream originated on one machine to deliver without any error into the another machine. It is also responsible for the fragmentation of data. It provides us the process to process delivery, and it is responsible for the flow control. Transport layer, another protocol work that on the transport layer, that is a connectionless protocol. It is UDP, that is user datagram protocol. So, in the user datagram protocol, it is unreliable connectionless protocol and your data is being transmitted in the form of datagram. It doesn't transfer in the form of packet. So, it never take the responsibility of it never provide any acknowledgement facility to the source. So, sequencing or flow control is not required here when where delivery is more important than accurate delivery. So, we are not bothered about the data is being actually received by the receiver or not. We have just transmit the data to the destination through the UDP protocol. An application layer, it uses various protocols at the TCP layer, at the TCP model. First protocol is used, that is Telnet. It is a remote login protocol. It allows a user on one machine to log into a distinct machine. Second protocol at the application layer, it is a FTP that provide a way to move the data from one machine to another machine in the form of text. Next protocol is a SMTP, that is a simple mail transfer protocol to transfer the mails over the net. And the last protocol is a DNS, that is a domain name system. It is used for mapping of host name onto the network addresses. So, these are the various layers at the of TCP IP reference model. So, this is a protocol hierarchy of the models: physical data link layer, network, transport and applications. Various protocols are work on the TCP IP reference model. So, thank you very much.